Okay, so this is how usually linear regressions are. They give you a computer readout, they give you graphs, and you are going to have to decipher them. You're going to have to know what is what. All right, so they asked us about the HO and HA. I'm just going to put it over here, A. So the HO is always that the slope is equal to 0. Okay, I need to read it to see what HA is going to be. Okay, they want to know if there is an association between math and reading. So my HA is going to be the beta 1 doesn't equal to 0. All right, so now let's go over to conditions. And so what, the scatter straight enough? And I am going to say that there is a linear trend in the scatter plot. Okay. Next one is independence, and I'm going to change my color. And I'm going to go up here. And remember independence, we look at the residual plot and we talk about pattern. And there is no pattern in the residual plot. You have to tell me which in the residual, which graph you're looking at. Okay, the next one is plot thickens. Okay, and I'm going to talk about spread. And do you see that the residual dots are kind of, all over the place? But the dots in the scatter plot, there seems to be some kind of very little spread between the dots. They seem to be a little bit tighter. So I'm going to talk about the scatter plot. And so there is an even spread. Even spread. And the scatter plots. Okay, the next one is nearly normal, and I'm going to talk about the histogram. So let's go just talk about this guy, nearly normal. Remember, we need to have a normal distribution. And so what is going to be, so the distribution of the residuals is symmetric without any outliers, without any outliers. And then I'm going to say conditions for T distribution have been met. Wow. I really used up that page, didn't I? Okay, so I went to go look up the answer because I wanted to know how to write it, because I don't do this that often, I admit it. All right, and I noticed that we don't divide by the square root of n, so silly Schwartz. It's just times the SE. So that means my interval here is going to be different, all right? You can see what the interval is in the back of the answers, but I want to explain about how they got the answer. Do you remember slope is the change, that slope is the change of y divided by the change of x. And on the scatter plot, they have reading scores as the vertical, math scores as the horizontal. All right? So we are confident. Oh, I guess I need to know what those scores are so that I can write it down here just a second. All right, so I had to go back and find it because I need the interval because I needed it for the conclusion. So we are 95% confident that and I'm going to talk about the reading scores because remember it's y over x, so that the reading scores are, now I got to say on average, okay, 0.646 to 1.086 points higher, right, because it's a positive, than the math scores. All right. Okay, so I'm looking at problem number 5, and they want to know about cars. And notice what I did. I kind of just made a little table. I labeled each car, what they observe, and what the percentage is. And I have to find the expected. So to find the expected for red, there's a total of 250, so that's 250 times 0.19. And I get 47.5. And for silver is going to be 250 times 0.162. And that's 40.5. And 250 times 0.147. For black is 36. 75, 36, 75. Green, 250 times 0.141. 35.25. White, 250 times 0.14. 35. And all the other colors, 250 times 0.22. And I get 55. Now, if I add up all these expected, they should add up to 250. Okay, so this is state an appropriate hypothesis. So why don't we just start this? I'm going to pick another color here. And I'm just going to say, so this is a goodness of fit test. And the HO is that, what are we talking about? Sample of our NASCAR's preferences typical of sports. So NASCAR color preferences are typical of sports enthusiasts. Gee, Winkies, who would ever thought I would spell this word in the math class? And then my HA would be NASCAR color preferences. Is not typical of sports enthusiasts. Okay? Let's do conditions. And so my conditions are, was it random? We will assume the cars are random. Assume. Assume cars are random. Counted. Each color was counted data. Each color was counted. Was counted. Okay, I'm going to go over here. I'm going to go back up here. I'm going to erase the HO and HA, all right? Because I need this space. And I'm going to change colors. So expected values. Each expected value is greater than 5. And you have to say expected values. Many of you guys just said values. Greater than or equal to 5. And you have to give me proof. And I have that proof. And notice that I labeled it expected values. So what do we have? Conditions for a chi-squared distribution exist. Okay? Okay, so now let's go do the math. So I'm going to erase all this stuff here. And remember, it's the very last formula on your formula chart at the very bottom.